Okay, next lesson. You got 2 assignments on this day. This is Thursday, February 27th. Tell her the function is exponential or linear. Now we know how to tell if it's linear. If it's going by the same amount every time, so that's a 3, 3, 3. That's linear. If you graph those points on a graph, it would be a straight line. Now, next one. It's not linear because that's a difference of 6. That's a 24, and then yeah. So it's not linear. We know that much. So here's how you check to see if it's exponential. You're going to make ratios. You start at the bottom. You take 128, always bottom, divide by 32. Then we're going to take 32 divided by 8, then 8 divided by 2. All of those divide into 4. So that means it's exponential because it's times 4 every time. So exponential is how that's written. If you want to abbreviate EXP, that's fine too. Okay, now this one, it goes by 5, 5, 5. That's linear. How about here? Well, that's down by 32 by 32 by 16 by 8. So how do we tell if that's exponential? Well, let's take the 8, set it as a ratio to 16, then 16 as a ratio over 32, then 32 over 64. Now, if I divide each one of those, you can see I'm getting the same thing every time. It's always 0.5, so that means it's exponential. Because every time I'm multiplying, it's by 0.5. Now it is going down. It's an exponential decay. That's an exponential growth. Okay, so that's what you do on the first part. Okay, the next part. Tell her the function is linear or exponential without a table. Here's how you look at an equation and tell. Find your independent variable x. What's the operation between the 5 and the x? Well, due to the fact that the 5's in the upper right-hand corner, that means it's a power. That means it would be an exponential function. Okay, y equals 12 times x. Now, what's the relationship of the 12 and the x here? Well, it's 12 times x. X is not, it's not 12 to the x power, it's 12 times x. That would be linear. Now let me explain why this is. Don't make the table. So if you go 0, 1, 2, here if you go 0, 1, 2, so 4 times 5 to the power of 0 is 4, because 5 to the power of 0 is 1 times 4 is 4. Okay, what's 4 times 5 to the first power? Well, it's just 4 times 5, that's 20. 4 times 5 to the second power, 5 to the second's 100 times 4 is, or 5 to the second is 25 times 4 is 100. So obviously that's not linear, but 100 over 20 and 20 over 4 is 5, okay? 12 times 0 is 0, 12 times 1 is 12, 12 times 2 is 24. That's up by 12, that's linear. So again, if the relationship with the x is that x is a power to the 5, then it's exponential. But if it's just x times 12, it's linear. X is a power, so that's exponential. Here, x is just a multiplied, okay, with the 7, so that's linear. You could do MB on that, it'd be a straight line. Okay, now the next one. These are all exponents. The x is always an exponent to the 2 to the power. They're all exponents. But you got to tell whether the function represents exponential growth or exponential decay. So what you're going to do on these first two is make a table. And then I'm going to teach you how to do it without having to make the table. So let's take 0.93 times 2 to the power of 0. It's going to be 0.93 when I hit equals because 2 to the 0 power is 1. Anything to the 0 power is 1. So that's a 1. And then what's 0.93 times 1? It's 0.93. Now, let's go 0.93 times 2 to the power of 1. So it's 2 to the first is 2. Now it's 0.93 times 2, which is 1.86. Now we'll take 0.93 times 2 to the power of 2. That's 4. It's going to be 4 times 0.93, 3.72. It's growing, okay? So it represents growth. Now let's look at this one. Okay, the first one's going to be 2. How do I know that? Because if I go anything to the power of 0 is 1, but you're taking the 1 times the 2, so that would be 2. Now 2 times 0.68 to the first power is just 2 times 0.68, 1.36. And now I take 2 times 0.68 raised to the power of 2, 0.9248. Now here it was growing, but here it's decaying. It's getting smaller every time we multiply, so that's decay. Now how do you tell that without a table? Well, you find your x power, and its base is 0.2, so I would be taking 68 times 0.2. This 0.2 is less than 1 whole, okay? If it's less than 1, if the base you're multiplying by is less than 1, then it's decay. Here, if the base is what I'm multiplying by repeatedly is greater than 1, it's going to be growth. So that's how you can identify that without the table. Now pause the video and then work on 1 through 12, okay? They go quick. You just have to write one word and I'm happy. Okay, now to the next problem. Turn the page on that and we're going to start with 4 story problems. The owner of an original copy of a comic book sold at an auction in the year 2005. The owner bought the book in 1980 for $55. The value of the comic book increased at a rate of 3% each year. How much should the comic book be sold for? Okay. You have 2 units here working together, the dollars and the years. So years is X, dollars is Y. So per, dollars per year. Problem is, it's not dollars per year, it's percent per year. If it said $3 each year, I would put 3x, make my line 3x in the middle, and put 55 at the beginning. But it's 3%, increase of 3%, so plus 3%. Okay, that means it ain't a line, okay? Here's how a percent rate of change works. Here's a table. In the year 1980, they sold the comic book for $55. Now, in 1981, it's increasing by 3%. How do we increase a price by 3%? Well, we have to multiply. And we're going to multiply by whatever 100% plus 3% would be. That's 103%. You need to make that a decimal, so you multiply it by 1.03. Now it's 50. Now after 1981, it was $56.65. Then multiply by 1.03 again. Now it's up to $58.35. Okay. Times 1.03 again. Now it's $60.10. Now I got a long way to go before I get to 2005, which is what they want to know. So I think we're probably going to need a little more efficient method than using this table, because I'm going to have to go 22 more times. So again, we said it wasn't a line because this is not increasing by a line, okay? The ratio, if you remember, here's how to prove it. So 60.10. So again, if I find these ratios, it's always 1.03. So with the percent, that means it's an exponential function. And if it's going up, that's a growth. So it doesn't matter if it's growth or decay, you're going to go with this base equation. You're not going to make a graph. You're going to put y equals a times b to the x power. Now I'll explain what to put in for those in a second. Now we're solving for the dollars, so I'm solving for the y. So I need y in this equation at all times. Now here's what the a means. The a is where the y started, so y is the dollars. How much dollars did it start with? It started with 55. So your a is 55. Now b is your growth factor. You come back over here, you take 100% plus 3%, and that's 103%. Now you got to make it a decimal, so it'd be 1.03. You got to have the 1 in front of it. It cannot be 0.03, otherwise the answer makes no sense. Okay, now x. Now x is years. What can I do with 2005 and 1980 to figure out how many years that is? Well, you could subtract and it'd be 25. Okay, and then I solve for y. We can just simply plug that into the calculator. 55 times 1.03 raised to the power of 25. Round to the nearest dollars, so then that's worth $115. Okay, and I would have got to 115 had I kept going on that table. Okay, you put $125 in a savings account that earns 2% interest each year. Interest makes stuff get higher. It's an adding. It's a growth. You make no deposits or withdrawals. How much will our investment be worth in 10 years? So again, you've got dollars and years. Problem is, the dollars per year doesn't exist because every year it's a percent. Okay, which is a game changer. That means you don't make the line and put the 2x. You would do that if it said $2 each year, but 2% is different. That's exponential, and that is a growth as well. So I put y equals a times b to the x power. Okay, so you're solving for the y, you leave that y alone. You're always going to be solving for the y. You don't really solve for any of the other variables until Algebra 2. So your a is where the y, the money, would start at. It starts at 125. Then the growth factor is, it's not 0.02. You got to take 100% plus 2%. That's 102%. So the growth factor is 1.02. To the power of x. Well, x is years, and it says we have 10 years. Okay, $152. Okay, I'll do two more. In the year 2004, a person purchased a car for $25,000. The value of the car decreased by 14% annually. That means per year. Annually means per year. Calculate the car's value in the year 2012. So you got dollars and years. But it's 14% per year, not $14. So the rate of change is not constant. It is not linear. Okay. So, but it's minus 14% because it's decreasing. So that's a exponential decay. You don't have to write that up there, I'm just saying. But you still use y equals a times b to the x power. To make it a decay, there's only one different thing you do. The a is your dollars, that dollars start at 25,000. Times your b, that's your decay factor now. So you take 100%, but instead of adding 14, you subtract 14%, and that's 86%. So that's 0.86. That's less than 1, hence it's a decay factor. I'm multiplying this by something less than 1, so it makes that decay. So to the x power, 2012 minus 2004 is 8. Okay, $7,480, and it decayed just like we said it was going to. Now, in the next problem, this actually could be done without algebra, but I'm going to show the algebra just to prove that this works. There are 128 teams at the start of a citywide 3-on-3 basketball tournament. Half, or 50% of the teams, are eliminated each round. How many teams are left at the beginning of the fourth round? So we started at 128. Well, after the first round, half of them are gone, okay? 64. After the next round, half of those are gone, 32. So 2 rounds gone. Next round, 16. So the answer to that problem is 16. Now let's set it up and see if we get 16. So you would have teams and rounds. So X would be the rounds, because rounds is like the times you play, and then Y is teams. So teams per round. Well, teams per round, half of them are gone. That's a percent. And they're eliminated, so it's 50%. So that percent means it's not a line, because this is not going down in a line. I mean, that does not change by the same thing every time. So it's an exponential decay. A times b to the x power. Okay, so the teams you begin with are 128. Then the decay factor is found by taking 100% minus 50%, that's 50%. So 0.50, and then X is the rounds. Well, you don't put 4 in, you have not played the fourth round yet, you're not, so it's 3. If I take 128 times 0.5, that's going to make it decay, raised to the power of 3, I get 16.